Oh, hello everyone. My name is Raghav. So today I am presenting my project on diabetes prediction system using machine learning. The main objective of this project is to predict whether a patient is diabetic or not, based on like several attributes like glucose level, BMI, and etc. To provide meaningful insights and also provide recommendations to the patient. So I show the dataset that I used in this process. So this is my dataset that I used. It includes like glucose level of the patient, BMI, and corresponding outcome. That means 1 and 0, in which 1 states that the patient has diabetes and 0 states that he has no diabetes. So for the machine learning I used a software that is Rapid Miner. It is a very good software for the machine learning process. It provides several kind of operators to use and inbuilt libraries like and algorithms that we can implement on a data. So first of all we import the dataset on diabetes here, and then apply set role operator, and we have a numerical data, so we need to convert it into the polynomial. So we apply numerical to polynomial operator. So after that do a machine learning on our project. So we have basically I apply two machine learning models on my project. First is decision tree and second thing is random forest. But one problem is that with my dataset is it is unbalanced. So when I apply decision tree model, I show you the results. Through the when I apply decision tree, I achieve the accuracy of 76.96%. It made the predictions like prediction 1 that it is truly made 29 and not 8. So it's but here the accuracy is low and the true prediction accuracy is high. So this is because my data set is in balance. That's why I use like a strategy to balance the data, which is I show you. I made a pipeline here, that is filter, multiply and append. I filter the data and based on the outcome that the person has diabetes and those which have no diabetes. After filtering I append the patients with the who has diabetes. That means I copy it again and append it. So then when I apply the cross validation operator, like I show, I apply random forest operator, then in cross validation my data gets balanced, and then I apply model and check performance. Then I will show you the result. So when I then wait a minute, let's see. Then when I balance the data, the accuracy reached to 85.61. When it is only 76.96, then after balancing and using the data set random forest, it reaches to 85.61. All the accuracy for 20, like a person has diabetes and a person has no diabetes, both get true. So this results in our increase in accuracy of the model. So this I find after this process that both models give accuracy. Like decision tree, I both use models separately, like also use decision tree first and then I use random forest separately without balancing the data. But the accuracy reach only like around 75 to 80%, but after balancing it reaches to 86. So it is the result. Like I compare two models basically, and to detect which is great, which gives us the better result. So in this way it predicts our model. Then I find the which operators is maximum contribution to in our patient has diabetes. Like I use weight by information gain operator. So when I find the like results in using weight by information gain, I find which factors are more contributing. Like I get the weight for each factors who contribute to a person is diabetic or not. So these are several attributes like blood pressure, one second, blood pressure, skin thickness, pedigree, function, insulin, pregnancy, age, BMI, glucose. And I see that glucose factor has a maximum weightage among them, that is 0.131. So it contribute maximum in this process, and apart from it all have less percentage. Then I see that BMI. So I create a decision tree for this. Let I see. I used decision tree operator to detect a like tree-like structure for this process. In the decision tree, I show like first maximum contribute maximum in this process. If my glucose level is greater than 127, then we see that our BMI branch will execute and it show that a person has a diabetes or not. Like show X, and we find that if it is BMI is greater than 29, and then the person is diabetic. So we have find a person like a person diabetes through this branch, but there are also some factors like glucose is less than 127 and the person is non-diabetic. So we get a idea like if a person has diabetes, then what the factors it will contribute. So this is the decision tree that I have created through this. And then there is a key feature of my project, that is it not only make prediction, apart from prediction it also give us the recommendations to the patient. Like what I do, I explain here. I set a recommendation system which tells the patient if he has diabetes what he needs to do. Like based on his factors, it will suggest a recommendation for the patient, so what he should adopt now. So this is the pipeline that I used for the recommendation. Also I can show you the results. Once in the results I will show. So this is the whole. Let a person is diabetes, glucose level 148 and BP 72, age 52. So that it will recommend the patient so that reduce sugar intake. If the person has glucose level 83 and age 32, then it will also reduce sugar intake. And if a person has glucose level 137 and age 33, then it will suggest exercise. So the system will suggest the patient based on its key factors. So this is the main feature of my project. And one more key feature I will show you. This first feature is that it makes prediction through comparing several machine learning algorithm, which is decision tree and random forest. In it also we have balanced and unbalanced data. Through unbalanced data we get a lower accuracy, through balanced data we get higher accuracy. And second thing is recommendation system, it recommends the patient based on its attributes. Third third feature of my project is like comparative analysis. In comparative analysis, system compares two patients and give insights based on the research. So basically I take a filter. I show you a like a person, I take a factor like glucose. If a person has greater than this amount 140, so I take another filter which like glucose less than 120. I take sample, one sample, only one sample from each, and rename, like, because I have to make comparison, so I change the attributes glucose, like glucose A to glucose A, BMI to BMI for the patient B, because we need comparison, so we need patient, two patients, patient A, patient B. So these are the attributes for two patients basically. Then nothing done. We because our system does not support Cartesian product, so we need to make these generate attributes of to make a common ID on which we make Cartesian product. So then I join the it may doesn't support vertical join, so I make inner join on it. Then I select attributes and then generate attributes, that is insights. So I show you what I want to say, like so this is the result. A patient A, glucose A, BMI A, AJ. It is a record of patient A. It is a record of patient B. So it has made comparison. Patient A has higher glucose level. If there is some other data, like if we change the sample, then the data of another patient will come, so it will make comparison between those. So this is a very like third feature of our project. So till I explain my the three features, that is predictions, second one is recommendation system, third is comparative analysis, in which we make comparison. So this is my project in which I made like machine learning algorithm and apply machine learning. So if I want to see the like one more thing, wait a minute, one second only. So this is the main thing, that is how we achieve accuracy. Like a person has diabetes, that is 0, then person holds that the prediction made by like ML algo, that is also 0, when it's 0 1 0 1 1 1 1 1. So it tells the confidence score that a machine learning model is like accurate in 0 and 1, this is 0.774, 0.869, that is the true. Also that it makes true prediction of the like man. So because as we told that I split the data for the prediction, I forget to explain this before. I split data because I need to make prediction in 70:30 ratio for the prediction, but when I made prediction for using random forest by balancing the data, then I haven't split it, because then it doesn't give the accurate result. So I made like more and more classified data to make it give more accurate result. So then I show that I achieve 86% accuracy. So this is my whole project that successfully demonstrate how machine learning used not only for prediction but also for generating insights and recommendations. Thank you.